for this problem, I need to think about how this function relates to our formula. How does this relate to 1 over 1 minus x, which is the summation as n goes from 0 to infinity of x to the n? Well, I know if I did the integral of 1 over 1 minus x, I know I can do that, and I'm thinking, okay, there's my ln. So the ln, this is a u substitution. Let's go ahead and do this one. So u substitution, u would be 1 minus x. And so du over dx is negative 1. So du is negative 1 dx. du over negative 1 is dx. So this would be the integral of 1 over u times du over negative 1. I could factor the negative 1 out. The integral of 1 over u du, and that is negative ln absolute u, and u was 1 minus x, and then plus c. So number 15 is going to be related to this type of problem. And thinking though, but I have 5 minus x. So I'm looking for this. How does ln 5 minus x relate to 1 over 5 minus x? Well, it's going to be the integral, but let's write this as a let's do the integral. So the integral of 1 over 5 minus x dx, well, that's a u substitution. U would be 5 minus x, and so u would be 5 minus x. du would be negative 1 dx. So it's the same as the previous, very similar. This would be the integral of 1 over u du over negative 1. So it's going to be negative ln absolute u plus c. So it's negative ln absolute 5 minus x plus c. So the idea on number 15 is this. Now it differs by a negative sign from what's written in the book, the natural log of 5 minus x, and this. But I can deal with that negative sign when I'm done with the problem. I can deal with that at the very end. So looking at this, if I can find a power series representation of this, of 1 over 5 minus x, then I can do the integral of each term. And I wouldn't quite have what they want on number 15. I would have the negative of what they want, but then I can just change the signs. So this is what we would work from for problem number 15. And let's go ahead and find the power series representation for this. So find a power series representation for 1 over 5 minus x. Well, I need to factor out the 5. So that's 1 over 5 factors out 1 minus x over 5. On this one, I already have the negative sign, 1 minus x over 5. So with my 1 over 1 minus u, which is the sum as n goes from 0 to infinity of u to the n, I just substitute x over 5 in there. Don't forget the 1/5. 1/5 times the summation as n goes from 0 to infinity of x over 5 to the n. You could leave the 1/5 factored out. You could put it back on the other side of the summation if you like. I'm going to leave it out, but I'll show you how to put it back in if you like. 1/5 times the sum as n goes from 0 to infinity, x to the n over 5 to the n. I just went ahead and put the n with both the numerator and denominator. And then if I multiply the 1/5 in, it'd be the sum as n goes from 0 to infinity of x to the n over 5 to the n plus 1. But when I work the problem, I'm going to work it probably from here for now. Yes? How is that?
Yeah, I was wondering how.
Oh, this was 5 to the first power. So when I did 5 to the first times 5 to the n, I just add the exponents. So I have the power series representation, and let me reevaluate what I just said. Do I want to work? It doesn't matter. I'll work from here, I suppose. You know what we could do? No, we can't do that. Okay, we'll work from, I'll work from here. So 1 over 5 minus x. In fact, the integral of 1 over 5 minus x dx, I know because we calculated it that that's negative ln absolute 5 minus x plus some constant c. And I know that now the integral of 1 over 5 minus x dx, I could say that's the integral of this power series. So 1/5 times this summation, n goes from 0 to infinity of x over 5 to the n dx. I probably factor this 1/5 across the integral sign. And basically what I need to do is the integral of each of these terms. 1/5 comes out. The integral of the sum as n goes from 0 to infinity, x over 5 to the n. My preference is to write out a few terms and do the antiderivatives and see what's happening. But you could do this from this step. All this is something raised to a power. Let's see. Oh, it's a u substitution, I suppose. U is x over 5. And so I would say then if u is x over 5, what is du? Du is 1/5 dx. Maybe I need this 1/5 next to dx after all. It would make the u substitution a lot easier. So I'm going to put that back in because it's actually a part of the du. So I get x, the integral of the summation of x over 5 to the n, 1/5 dx. This is the du. This is u. So what do you do for the antiderivative? You're going to add 1 to the exponent. It would be n plus 1, x over 5 to the n plus 1, divide by n plus 1, and I'll put on, this kind of got swallowed up with the du, plus c. This is not quite what they wanted us to find. And I probably should say, let's go ahead and find a value for c. I'm not going to do that part of the problem. What they wanted us to find was the positive. So what can we do? Just multiply both sides by negative. So what I end up with is ln absolute 5 minus x plus c. I'm not quite sure about the plus c, but it's going to be negative. Now that negative is on the outside. It's not raised to a power.